Have you ever looked up at the vast, star-dusted night sky and felt a sense of profound wonder? Have you ever considered that this intricate tapestry of life, this grand cosmic dance, might be something other than what it appears? It is a curious thought, one that has tickled the minds of thinkers for centuries. Could it be that our reality, everything we see and touch and feel, is not the base reality at all? It is a startling proposition to imagine that our world, in all its breathtaking complexity, could be an elaborate computer game, a meticulously crafted simulation running on some unfathomable cosmic hardware. We, and all the life we share this planet with, might simply be characters within this grand digital stage. The idea, known as the simulation hypothesis, suggests just that. It posits that our universe is an artificial reality, generated by a far more advanced civilization. Remarkably, this seemingly outlandish idea has found a home not just in science fiction, but in the halls of modern physics and philosophy. The esteemed Oxford philosopher Nick Bostrom presented a compelling argument in 2003. He reasoned that one of three propositions must be true. Either civilizations like ours almost always go extinct before developing simulation technology, the world of quantum mechanics, that strange and wonderful realm of the very small, also provides some tantalizing hints. Here, at the subatomic level, reality appears to behave in a most peculiar way. Particles, it seems, do not have definite properties like a specific location until they are observed. This is not unlike how a video game might render details. The world behind you in a game doesn't truly exist in high fidelity until you turn around to look at it. This saves computational power. Could the universe be doing the same, only rendering the fine details of reality when a conscious observer is there to measure them? The universe appears to be governed by a set of finite mathematical laws. The speed of light, for example, acts as a cosmic speed limit, a maximum processing speed for the universe. The Planck length represents the smallest possible unit of space, suggesting that reality might be pixelated, made of discrete units, just like a digital image on a screen. This brings us back to our own burgeoning technology. We are, ourselves, becoming creators of digital worlds. From simple pixelated games decades ago, we now craft photorealistic virtual realities that can fool the human eye. We create artificial intelligences that can learn, adapt, and even communicate. We are taking our first tentative steps on the path that, if followed to its conclusion, could lead to the creation of our own ancestor simulations. If we entertain the notion that we are living inside a simulation, an immediate and compelling question arises. Who are the simulators? Who are the architects of this magnificent and complex reality? They could be beings not unlike ourselves, perhaps our own distant descendants running a simulation to study their history. An ancestor simulation would be an invaluable scientific tool, allowing them to understand their origins with perfect clarity, to watch the grand pageant of evolution and civilization unfold as if they were there. For them, our entire existence might be a single, fascinating research project. Another possibility is that the creators are something far more alien, beings whose motivations we could scarcely comprehend. Perhaps they are not biological at all, but a form of post-biological, super-intelligent artificial intelligence. A being of pure information, existing on a plane of reality so advanced that our universe is, to them, a simple curiosity, a piece of art, or perhaps even a form of entertainment. We might be living in what is known as a full simulation, where the entire universe, down to every last atom, is being simulated from the ground up. This would require an amount of computational power that is truly staggering, far beyond anything we can currently conceive. Alternatively, we could be in a more limited simulation, one focused solely on Earth and its inhabitants. The distant galaxies we observe through our telescopes could be a simple two-dimensional backdrop, a skybox like in a video game, designed to give the illusion of an infinite cosmos without requiring the resources to simulate it all. This line of thinking also alters our understanding of a higher power. Could the creators of the simulation be considered our gods? They would have the power to intervene, to alter the laws of physics, to perform what we would perceive as miracles. Our prayers might be nothing more than bug reports or feature requests sent up the chain of command. This doesn't necessarily imply a benevolent creator. The simulators could be indifferent scientists or even cruel children playing with a sophisticated toy. Of course, this extraordinary claim requires extraordinary evidence and, many brilliant minds remain unconvinced. The simulation hypothesis, for all its intrigue, faces significant challenges. One of the primary arguments against it is that the theory is, for now, largely unfalsifiable. A key principle of the scientific method is that a hypothesis must be testable. There must be some conceivable experiment that could prove it wrong. But how could we ever definitively prove we are not in a simulation? Any evidence we find, any glitch or inconsistency, could simply be part of the simulation itself, designed to be found. Furthermore, critics argue that the logic used to support the hypothesis has its own flaws. The argument that we are likely in a simulation because future civilizations will create many of them relies on a great number of assumptions about what those future civilizations would be like and what their motivations would be. Perhaps advanced societies would have ethical prohibitions against creating conscious beings trapped in a simulation. We are projecting our own current technological fascinations onto a hypothetical, unknowable future, which is a precarious foundation for such a grand theory. There is also the sheer, mind-boggling complexity of our reality. To simulate a universe like ours, with the quantum weirdness and the intricate dance of billions of galaxies over billions of years, would require a computer of unimaginable power. Some physicists argue that simulating quantum systems is so computationally expensive that it would be impossible for any computer existing within our own laws of physics to do so. The universe that contains the simulator would have to be vastly more complex than the one it is simulating. This leads to a problem of infinite regress. Who then is simulating the simulators? Finally, there is the simple, powerful argument known as Occam's razor. This principle suggests that the simplest explanation is often the correct one. Is it more likely that we are living in a base reality, a universe that simply is, governed by its own inherent laws? Or is it more likely that we are in a simulated reality, created by an unknown advanced civilization for unknown reasons, running on an unknown type of computer existing in another, higher, reality? For many, the idea of a simulated universe, while a fascinating thought experiment, adds a layer of unnecessary and unprovable complexity to our existence. In the end, we are left standing at the edge of a profound mystery. The simulation hypothesis is a mirror, reflecting our own technological progress and our deepest anxieties about the nature of reality. It takes an ancient philosophical question and dresses it in the language of the 21st century, with code, pixels, and processing power. We have explored the tantalizing clues, from the strange behavior of the quantum world to the mathematical elegance of our universe's laws. We have considered who our creators might be and why they might have set this grand program in motion, and we have listened to the strong, reasoned voices of skepticism. The debate itself is a testament to the curiosity of the human mind. The fact that we can even conceive of such a question is honestly remarkable. It pushes us to test the very limits of what we know and what we think is possible. Some scientists are even proposing experiments to search for evidence. They wonder if we might detect the pixels of our universe if we could probe to a small enough scale, or if we might find glitches in the code, inconsistencies in the laws of physics that reveal the simulation's artifice. The search for these answers, whether they lead to a confirmation or a refutation, will undoubtedly deepen our understanding of the cosmos. But what if we are in a simulation? What should we do? Perhaps the answer is simply nothing different. If this reality is a simulation, it is an astonishingly good one. The joy of discovery, the warmth of companionship, the beauty of a sunset. These experiences are no less valuable to us, the inhabitants of this world. Our lives, our struggles, and our triumphs are still real to us. The search for knowledge, kindness, and meaning would remain just as important. The best way to live in a simulation may be to live a good life, to be a good character in this extraordinary story. And so the question lingers in the air, as subtle and persistent as the background radiation of the cosmos. How can we truly know what is real? Are we the products of billions of years of cosmic evolution in a base reality, stardust given life and consciousness? Or are we the fleeting thoughts of a machine, a complex echo in a program written by an unseen hand? As we continue to explore our world from the smallest particle to the most distant galaxy, we are, in essence, exploring the boundaries of our own existence. And that, surely, is the greatest adventure of all.